Okay, so since I already told you, this is the one of the method of Boolean function simplification. So here I'm just mentioning one example, that is find the minimal SOP for the Boolean expression, that is f is equal to summation 1 comma 2 comma 3 comma 7 comma 8 comma 9 comma 10 comma 11 comma 14 comma 15 by using Quine-McCluskey method. Actually SOP means sum of product form. So actually in the input they just given the SOP, that is sum of product form, and the method they asked us to use is Quine-McCluskey method. So we'll enter into the sum solution. So first what we have to do now, first we have to mention the binary numbers for the input. See here, I am just mentioning the first table. There are a lot of tables will be there in this method. So that is why the another name of this method is the tabulation method. So first the table number one is a binary representation of min terms. Okay, so whatever the terms they are given in the inputs. For example, this is the input. Okay, for these inputs we are going to represent the binary numbers. For example, if it is 1 means that is in terms of 4 digit we have to mention the binary number. That is if it is 1 means 0001. That means like 8421 concept. With the help of 8421 concept we are going to represent number. For example, if it is 15 means, so 8 plus 4 12, 12 plus 2 14, and 14 plus 1 is 15. So that means all the 4 digit having 1. Okay, so with that concept we are going to represent the numbers. See here, this is what the binary representation of min term table. See, for 0 actually in this table I mentioned all the inputs, that is from 0 to 15, but no need to mention like this. Whatever the input we required, that is whatever the input in the sum they given, so for that alone representation is enough. For example, here you can see 1 comma 2 comma 3, so that is why I just to make a tick mark here. Okay, that is 1 2 3 7 8 9 10 11 and 14 and 15. Okay, so this is what the representation of binary numbers. Okay, so with the help of 8421 concept we are going to represent the binary numbers for the input. So that is the first table, and next we are moving for the second table. So you can see the above binary representation are grouped into the number of section in terms of group of ones. That is what the second table. So the name of the second table is group of min terms for, you can see, group of min terms for different number of ones. Okay, so for example, if it is 1 means, so this is the representation. Likewise, if it is 3 means, this is the representation, right? This is the binary representation of 1, and this is the binary representation of 3. Okay, so in this you can see for the first input we have only one number of ones, but in the second input we have two number of ones. Okay, so likewise we have to grouping the min terms. That is what the table number 2, that is group of min terms for different number of ones. Okay, so according to our input, okay, so you can see this is what the column of the table, that is number of ones, min terms and variables, that is a b c d, that is 4 bit. Okay, so according to our input the number of ones, okay, the number of ones is listed like this. That is a one number of ones, one number of ones, two number of ones, three number of ones, and then four number of ones. Okay, so we'll see one by one. So you can see, so from the inputs, that is so 1 2 8 having only one number of ones, you can see. So one, for 1 the representation is 0 0 0 1, and for 2 the representation is 0 0 1 0. Likewise for the 8 the representation is 1 triple 0. Okay, so in this you can see only one will be present inside the bit. Okay, so that is what the representation. And then next representation is two number of ones. So for two number of ones according to the input, so 3 9 and 10 having two number of ones. You can see for 3 0 0 0 0 1 1, so two number of ones will be there. So likewise you have to mention in this table. Okay, after completing the two number of ones, next we'll move into three number of ones. For example, the example for the three number of ones is 7. Okay, so what is the concept for 7? 0 triple 1. Okay, so 0 triple 1, so that means we have three number of ones. Okay, so likewise I mentioned. Okay, so totally we have four groups, that is one number of one, two number of ones, 3 number of ones and 4 number of ones. So this is what the table number 2. So the table number 1 is binary representation of given inputs, and the table number 2 is a group of number of ones. And we'll move into the next table, that is so the next table name is two cell combination. You can see, as I mentioned here, two cell combination. So what we have to do it in the two cell combination now, you can see from the second table we are moving to the two cell combination table. Okay, so what we have to do now, for example, let me take this row as a and this row as a B and this row as a C and the last row as a D. Okay, so now what we have to do now, we have to compare A with B and B with C and C with D. Okay, so we have to compare. Okay, and what we have to compare now, okay, for example, so in the A row we have three inputs, that is 1 to 8, and B row we have three inputs, that is 3, 9 and 10. Okay, so we have to compare each with other sections inputs. For example, 1 comma 3 we have to compare. So next to 1 comma 9, next to 1 comma 10. Likewise, we have to compare. So totally we have so 3 into 3, 9 comparisons will be there. But what we have to write in the one cell combination now. So for example, if we compare 1 comma 3 now, okay, so if we compare 1 comma 3 now, you can see here 0, here also 0, and then here 0, here also 0, and here 0, here 1. One bit will be changed, right? So one bit will be changed. Likewise, here you can see 1 and 1. So totally only one input will be changed. So likewise, we have to get the combination. That is what the table of two cell combination. Okay, so we have to compare the A row with B row and B row with C row and C row with D row. So the condition is, for the comparison, only one input variable must be changed. Okay, if more than one input variable is changed now, so no need to take that. Okay, so that is what two cell combination. You can see, let me show you it. You can see, so according to the concept, you can see, so 1 comma 3, 1 comma 9, 2 comma 3 and 2 comma 10, 8 comma 9, 8 comma 10 will be there. So this is the row because of the comparison of A comma B. Okay, so if you combined A and B now, so these are the combination will be present. So that means the condition is only one bit will be changed. So that changed bit will be represented by dash. Okay, that is the concept. I hope you understand. So likewise, if you combine B with C, means you can have this combination, that is 3 comma 7, 3 comma 11, 9 comma 11, 10 comma 11 and 10 comma 14. Okay, 10 comma 14. So let me show you one example, 3 comma 7. We'll see with the previous table. You can see, so the third actually the third representation is 0 0 1 1 and the seventh representation is 0 triple 1. Okay, so now how we can compare now? So 3 comma 7. Okay, you can see 0 0, so no changes, and 0 1, so one bit change is already happened. Okay, so hereafter uh, no bit will be changed. If no bit will be changed now, we can take it as a combination. Otherwise, we have to leave it. Okay, so 0 0 no issue, and 0 1 so one bit is changed, and 1 1 no changes, again 1 and 1. So that means this 3 comma 7 combination is valid combination, which will be present in the two cell combination table. So we have to mention like this, that is 0 dash 1 and 1. So that is what the concept of two cell combination. I hope you understand. Okay. So, but the thing is, you have to combine with A with B, that is A row with the B row, and B row with the C row, and then C row with D row. Okay. So you can see, so this is the combination of C with the D. Okay. So A comma B, B comma C, and C comma D. Okay. So this is the combination. So now the two cell combination table is over. Okay. So the next is, I hope you know. So the next table name is a four cell combination. Same concept. So now the number of rows, actually 4 rows will be reduced to 3 rows. Okay. So now what we have to do? The further reduced 3 rows will be further reduced with 2 rows. That is the concept of four cell combination. Here the concept is same. You can see, now consider this is A and this is B. This is row B and this is A. Now you have to compare A with B and then B with C. Okay, so B with C. Okay, now the condition. What is the condition now? You can see we have to again compare 1 comma 3 with 3 comma 7, 3 comma 11, 9 comma 11, 10 comma 11 and 10 comma 14. And the condition is, you can see if you compare 1 comma 3 with the other terms, that is the other terms which will be present in the two cell combination. Okay, so what is the condition now? In the 1 comma 3 la, where the dash will be there, you can see this is A, this is B and this is C and this is D. Okay, so that means, so C position la we have a dash. Okay, so likewise the same position having dash, in addition to that one more variable will be changed. We have to take that as a combination. That is the case. Okay, you can see 1 comma 3. Okay, 1 comma 3 la we have a dash in C section. So likewise where we have the dash, here you can see 9 comma 11 having the dash in C section. So now we have to compare 1 comma 3 and 9 comma 11. So we'll see, we'll compare. Okay, so 1 comma 3 and 9 comma 11. So what is the combination? You can see 1 comma 3 la 0 0 dash 1 will be there, and 9 comma 11 la what is that? 1 0 dash and 1 will be there. Okay, now you can compare, that is the four cell combination 1 comma 3 comma 9 comma 11. So what is the output? You can see 0 1. So bit changed. Okay, so that means we have to mention dash and 0 0, so no issues, and already dash is there, so already 1 will be there. So this is what the next combination concept. Okay, already dash will be present, so that only we have to take, and in addition to that one more variable will be changed. So that is what the concept of four cell combination. So as you can see, I already completed the four cell combination. So now you can see the three rows, that is the reduced table, that is two cell combination we have three rows. So that three row will be converted into two rows. That is these are the combinations. So you can see this is now A and this is now B. Okay, so in the A row what are all the combination? 1 comma 3 9 comma 11, and 2 comma 3 10 comma 11, and 8 comma 9 10 comma 11, and then B row 3 comma 7 comma 11 comma 15, and then 10 comma 11 comma 14 comma 15 will be there. Okay, so these are the combination, and the name of the table is you can see here, I'm just to mention four cell combination table. So the name of the table is the four cell combination table. Okay, so once you completed the four cell combination, you have to check one important thing. What is the important thing now? You can see in the two cell combination there are several combinations are there. Okay, so all these combination must present in this combination. So that is what the checkpoint. Okay, if the combination is not present now, we have to include that in a separate row. That is the concept. For example, you can see 1 comma 3. Okay, so in the A row what are all the combination will be there? 1 comma 3 1 comma 9 2 comma 3 2 comma 10 8 comma 9 8 comma 10. Okay, so you have to check 1 comma 3 is present here, and 1 comma 2 comma 3 is present here, and 2 comma 10 is present in this table. Okay, so likewise you have to compare. If any one of the combination is not present in the fossil combination, now you have to include that in the separate row, that is C row we have to include. But fortunately all those combination, that is all the two cell combination variables are present in the four cell combination table, so no need to worry, right? So we'll proceed the next step. Okay, so the next step is that is next table name is prime implicance table. You can see the, I'm just mentioning the title, prime implicance table. Okay, so in that there are several columns will be there. So the first column is prime implicance. So what we have to mention it in the prime implicance now, the four cell combination inputs. So you can see we have a totally 3 in the A row and 2 in the B row. Okay, so that will be mentioned here. And after that, the next columns. Okay, so the remaining columns are whatever the input we have. That is in the sum la, that is in the example la, they give one input. No. Okay, so that is sum f is equal to summation m 1 comma 2 comma 3 comma 7 comma. So likewise some inputs there. No, so that input you have to represent it here. Okay, and now the next step is we have to mark it. Okay, so what we have to mark it now? For example, you can see what is the combination here? 1 comma 3 comma 9 comma 11. Okay, so that means 1. So this one will be marked here. Okay, see here I'm just mentioning x, and then 3 will be marked here, and then 9 will be marked here, and 11 will be marked here. Likewise we have to mark all the variables, that is all the combinations we have to mark with the help of X. Okay. So once you marked all, next what is the procedure now? So we have to check vertically. Okay, we have to check vertically. You can see uh, one only one X will be there, no? So we have to take that combination. That is the concept for the next. Okay, you can see here only one X is there. Okay, so that means that combination will be present in the output. That is the concept. Okay, and after that here you can see here also only one X will be there. So that means this combination also present. But here you can see the third column we have 3x will be there. So that means this not be present, this will not present in the output. So likewise you have to mention. Okay, so here see here only one dash will be there. So that is we can take that in the output. So likewise we have to mark it. Okay, so after marking the tick mark, okay, so after marking the tick mark, so what is the next procedure now? So you can see this tick mark. Okay, how this tick mark is happened because of this X. Okay, so this tick mark, this X, this tick mark is responsible for this X, and this X is responsible for this combination, isn't it? Okay, so that means this combination will be present in the output. Likewise you have to mark it again. You can see one more X mark is here, no? Okay, so how it is happened? So because of this combination, so that means this combination also present in the output. So likewise you have to take it. So fortunately all these combination will be present in the output. Okay, so the final method is simplifying those combination to get the final output equation. So that is very simple, like slashing methods. Okay, so for example, so the first combination is 1 comma 3 comma 9 comma 11. Okay, so for these combinations we have to write the binary representation. For example, let me write it here. 1 what is the representation? 0 0 0 1. And for 3 what is the representation? 0 0 1 and 1. And for 9 what is the representation? 1 0 0 1. And for 11 1 0 1 1. So for the first combination, that is 1 comma 3 comma 9 comma 11, this is the representation. Now just to mention it, this is A, this is B, this is C, and this is D. Okay, now the basic slashing methods, that is the K map, finally we use on slash method, no? So that method we have to apply it here. Okay, you can see now check it vertically. If the inputs are changed now, that variable not present in the output. So see it here vertically, you have to check it 0 0 1 1. So that means the changes will be happen. So A is not there in the output. Now you can see B, there is no changes. So B will be there. That is, there is no changes means what? You can see 0 0 0 0, all will be zeros. So it will be there. And C, you can see Z 0 1 0 1. So changes will be there. So C will not be present in the output. And D, you can see 1 1 1 1. All ones are there. So it is also there. Okay. So in that, if it is 0 now, we have to put it like bar. For example, all will be 0. So that is why I'm just mentioning B as a bar. And here you can see all will be 1. So that means without bar. So the first product term in the output is B bar into D. So likewise, you have to do for all the combination. If you do it for all the combination, then the final result will be F is equal to B bar into D plus B bar into C plus A B bar plus C into D plus A into C. So this is what the final output for this tabulation method. That is the input given is F is equal to summation M 1 comma 2 comma 3 comma 7 comma 8 comma 9 comma 10 comma 11 comma 14 comma 15. So that will be minimized into F is equal to B bar into D plus B bar into C plus A B bar plus CD plus AC. So that's all. That's all about the tabulation method. I hope you understand. In case if you have any doubts, please let me know. So please mention it in the comment box so that I'll clarify your doubts. Thank you. Thank you, students.